Good morning, dear students. Today we'll discuss about the introduction to electrical transformer. Have you seen the transformer? Yes, transformer is fitted in the electrical substation. Or in each electrical substation, we are finding the different type of transformer. Now today we'll discuss about the electrical transformer. Transformer is a machine that transfers the electrical power from one circuit to another without changing the supply frequency. In other words, we can say electrical transformer is a device which is used to increase or decrease the voltage level with alternating decreasing or increasing the current in the power systems. That means we use the transformer generally to increase or decrease the voltage level with corresponding increasing in decreasing of current in the power systems. And also it operates in the principle of electromagnetic inductions. We know that we have two types of inductions. That is, one is self-induction principle, another one is mutual induction principle. Generally, the transformers works on the mutual induction principle. It is also very much essential equipment for the power transmissions and distributions across the long distance. Now next, we can say the transformer is also a static device. Why it is static? Because there is no rotating parts inside the transformer. We will briefly discuss about the transformer in our construction slide. Next construction at the time of construction or design of transformer. But you remember that transformer is a static device and it helps to transfer the electrical energy between two or more circuits. Its primary purpose is to step up or step down the voltage level to match the specific requirement. That means according to our requirement, we can increase or decrease the voltage. Now this also helps to reducing the power losses and also ensuring the safe operation in electrical equipment. Now come to the types of electrical transformer. According to the design and supply level, the transformer can be of various types. The main types include, that is, step up and step down transformer and also isolation transformer. I have already discussed that step up transformer which they increase the voltage from primary winding to secondary side, and also the step down transformer used to decrease the voltage level from primary to secondary side. Again, we have also power transformer that is only used in the transmission network level. That means we know that generally the electrical system is broadly classified into generation, transmission and distribution system. Again, our power transmitter is basically used for the transmission networks, while as the distribution transformers, that means the distribution transformers are also used in the several local areas or local substations in which the low level voltage are working. Again, the special transformer like instruments and audio transformers are also specific applications. Again, come to the constructions of transformer. According to as shown in the figure, we can see that is two types of winding are wound in a single core. Okay, that is the rectangle core it is showing. And it is also saying that the typical transformer is consist of two coils, and one is known as the primary coils and other one is the secondary coils, and both the primary and secondary windings are wound on a magnetic core, and the core is usually made up of laminated silicon steel, generally to reduce the ED current losses. We can say that the losses, to minimize the losses, we are used or made the laminated silicon steel. And also We are insulated the material between the windings core. That means the core windings also insulated to prevent any short circuit between the windings and the core. Now come to the working principle of the transformer. When alternating current flows through the primary coil, that means there is one current is flows, it creates varying magnetic flux in the core. Again, this changing magnetic flux, when comes in contact with the secondary coil, according to Faraday's laws of induction, it induces a voltage in the secondary coil. And this the ratio of voltage in the primary and secondary coil depend upon the turns ratio. That means the number of turns in the primary and the secondary coils. Now come to the voltage transmission ratio. That voltage ratio or voltage transmission ratio, transformation ratio is nothing but the ratio between the secondary and the primary voltage in the coils, and that primary voltage or secondary voltage is depend upon the turns of the coils. That means the secondary turns, if the secondary turns or primary turns is secondary turns is more than the primary turns, then we can say this is a step of transformer. That means what? Step of transformer means what? We are primarily giving the low voltage and we are getting the higher voltage in the output side, as there is a much more larger primary number of turns or larger turns than that of primary winding. And similarly or consequently we can say if there is a less number of secondary turns as compared to the primary turns, then it can be said that that is a step down transformer. Could you understand my points? Okay, let's come to the efficiency and losses. The transformers are also very highly efficient, as there is no rotating parts and there is losses is less as compared to the other equipment. That's why its efficiency is very high, that is nearly about 95%. Okay, now the core losses, that there's the two type of losses we know, that is core losses and copper losses. And here in this case the core losses include the hysteresis and eddy current losses, which depend upon the force of the material, whereas the copper loss occur due to the resistance in the windings, which affecting the overall efficiency of the transformer. Now comes to the application of electric transformer. Now the transformer are also used in the power generation, transmission and distribution. I have told previously also that transformer is used in all cases of electrical system, that is in the generation, transmission as well as in distribution system. They also provide the voltage regulations for our household and industrial electrical equipment. And some specialized transformers are also used to electronics and audio systems and also in medical requirements. Now come to the advantages of using transformer. We know that the transformer is a very efficient to transmit the electrical power from one place to another, and due to this only transformers only we can transmit the electrical power from one place to a long distance, okay, from generating station to a long distance for utilization purpose. That's also this is, and due to this is due to only possible or due to transformer. So transformer is a very vital or efficient equipments. Okay, and also they also allow the safe voltage level are suitable for various applications. And transformer also are reliable with simple constructions and low maintenance requirement. That means as there is no rotating parts inside the transformer, there is a static device. That's why it's very simple to construction as well as low maintenance is required. Now come to our conclusions, that electrical transformer is also very vital components for modern electrical infrastructure. And the advances in electrical materials and design, it helps to improve the transformer efficiency as well as the performance. and the emerging technologies like smart transformer, which aims to enhance the grid stability and the energy management. Understood? These are all about our introduction of transformer. Thank you.